Okay. Your name is Alex Kirchner, and you are the Chief Meteorologist for WREX in Rockford, Illinois, right?
That's correct. Alex Kirchner, Chief Meteorologist at WREX in Rockford, Illinois. And I got my degree in Atmospheric and Oceanic Sciences from the University of Wisconsin-Madison, and I'm also certified through the American Meteorological Society.
Okay, today we're going to be talking about acid rain. That is something that, for me, I had to look it up to even discover what it was. It's not something that was really covered when I was in grade school or anything. But what I wanted to ask you is, could acid rain occur naturally in the atmosphere?
As far as I understand, I do not believe that acid rain has a natural cause. Most of the causes come from pollutants going into the atmosphere from burning fossil fuels, from burning car exhaust, that type of stuff. You're looking at sulfur dioxide and nitrous oxide, I believe, and those chemicals, as they get into the atmosphere, they bond molecularly with hydrogen dioxide, rain. So they bond with the rain molecules and then or water molecules, and they fall back to Earth that way. So I don't believe there is a natural cause to all of that. Maybe if there is a pretty massive forest fire, but the rate that fossil fuels are burned, it's just that is the primary cause for all of that.
Is it called acid rain because the molecules that rain bonds with, are they acidic in nature? Is that why it's called acid rain?
What those molecules, when they bond with the water molecules, they end up becoming acidic. So they may not necessarily be acidic in nature on their own, but when they are combined with water, that's when the pH level does go down. I think that EPA says about a 4 to 4.2 on the pH scales, what they consider acidic. That's on the acidic side of things. And of course, the lower the number, the more acidic things are, but that threshold's about a 4.
In my research, I found that as you mentioned, that burning fossil fuels and other natural resources can cause acid rain. Do you believe that nuclear power is a better alternative in terms of that, or does that have its own set of problems in terms of pollutants?
So with nuclear power, it's a very good question. That has its drawbacks. You're dealing with radioactive material as a byproduct, which is not a fun thing to have, but at least with that, it's only releasing water vapor, so it's not releasing all those other harmful chemicals. So you kind of take the good and the bad with nuclear power, but at least with that, you're not releasing as many corrosive elements into the atmosphere, so that would be a good source to kind of get away from putting those extra pollutants into the atmosphere. But again, you're dealing with radioactive material and all that, so that's the unnecessary byproduct.
Okay. In my reading, I found a mention of acid fog, but they didn't do a whole lot of information on it. Is that something that happens rarely? Does it happen a lot?
I believe acid fog is a pretty rare occurrence. I think you have to have the right elements to have a thick fog, and then also have those other ingredients, the sulfur dioxide, the nitrous oxide, present in the atmosphere at levels that can bond with the air or the water molecules in the air. So I see that being a very rare occurrence, but there are a couple of historical occurrences where there were people hurt and injured and killed with very corrosive fog from an inversion that stayed in place for a couple of days right next to a big industrial area. So I think on rare occurrences it can happen, but the reason why it's not getting a lot of publicity necessarily is because it doesn't happen very often.
So then acid fog can form anywhere fog can form?
Essentially, yes.
Okay. Another thing that I wanted to ask was about areas where soil has very poor buffering capabilities, and that can make bodies of water in the area when acid rain falls even more acidic. Is that something that nature can redo on its own? Is there a way to enhance the buffering capability of soil?
I believe there are ways to change up the soil so that it's able to absorb some of that acidic compounds before they leach into the lake. There's probably ways to do that. It's probably not easy to do, but I think there are ways to prevent all that seeping into bodies of water surrounding where the acid rain is falling. You just have to take those preventative measures. Just the way the water cycle works, just because it's not having acid rain occur in one spot, that can all go through the groundwater and leach into other lakes and things. So you can probably have ways to slow all that down if you were able to change up the composition of the soil.
Can the bodies of water that are acidic, can they naturally repair themselves over time?
I don't believe so. I think that would be something that they would need help with, or it's going to take an awfully long time for that pH balance to return. It's not something that's going to occur over a short time scale, that would be a very long time scale before things manage to return to the natural pH levels that the lake or body of water was at before.
Okay. My research indicated that the acid rain program has a 100% compliance rate. With that in mind, do you believe that that compliance program goes far enough in terms of controls for pollutants in the air?
I believe that you could always do better. Even with a 100% compliance rate, you're still not necessarily eliminating every single one of the sources that could produce that acid rain. So even with a lot of kind of preventative measures, there's still going to be some that will escape and kind of occur and all that. So it could always be better, but a 100% compliance rate is still doing very, very well.
Do you believe that the efforts that started with the founding of the EPA in 1970 that have continued to the modern time, do you believe that they're making a big enough difference in both the short term and in the long term in terms of controlling the pollutants?
I think any kind of program is going to have benefits even if it doesn't do much. At least it's taking that step and you're starting to make a difference out there. So I think in the short term and the long term, the programs that are in place are making a difference. We don't talk a ton about acid rain, I think, because the programs in place have got a pretty good handle on it. Because we're still burning fossil fuels and things, we'll still always have the potential problem there, but I think the programs in place now, short-term and long-term, are going to have benefits and continue to have benefits.
Okay. One thing that I'm kind of curious about, I mentioned it earlier in the interview, is that as a kid I never really heard anything about acid rain. Now, given that was at the start of the acid rain program, it was in its infancy. I'm 36 years old, and they don't really have, or didn't really have, any education for that. Do you feel that in terms of acid rain and other pollutants, that the education system goes far enough to educate students not only in what can pollute, but in terms of educating them so they don't pollute?
That's an interesting question, or it's kind of a tough question, because I'm kind of in the same boat as you. I didn't hear a ton about or learn about a ton about acid rain growing up as a kid and all that, but things have changed. I guess I'm not too familiar with what's going on in the classroom right now, but I think with the advent of the internet and all sorts of websites and things, different outreach programs, the education is probably better, or at least there's more sources of information, ways to get that information out there, so students and teachers can discover and research different ways where that information wasn't available necessarily in the past. So I'm not, again, too familiar with what may be out there right now, but I do know that there is better awareness about it, there is better information about it, there's more research going on, and that all sums up, it all helps the situation, and as we continue to learn, I'm sure there'll be more avenues to approach this problem.
One last question. Do you believe that there is a single most important aspect of acid rain that all of us should understand?
I think with acid rain, there's a couple things that you probably should know about it. One is it's not like it's going to turn the rain into the acid that we see in TV shows and movies where it comes down and it just burns everything up and corrodes everything instantly. It's acidic enough that it affects plant life, it affects agriculture, and it affects erosion and all that, and stone and natural formations and things like that, but it's not so corrosive that it's just burning everything up instantly. It's acidic enough that you're going to see those impacts over time. It's going to start killing things off. It's going to start eroding things faster. So that's one thing to know about it, that you may not see the effects right away, or you may not be aware of that, but it's definitely out there. And number two, it's something that can be prevented the more we go towards more renewable resources and stop putting as many pollutants into the atmosphere.
Well, I appreciate your time, Alex.
No problem at all.
And I hope that this interview is not only educational for me, but for anybody who might actually see it.
Sure. I hope so too. It was a pleasure talking to you about this today.
Thank you very much.
Thank you.